Welcome everybody for this presentation of our software SDC Verifier, which is an add-on on Ansys. And I would like to show in this webinar a couple of things. I want to show you, okay, what is our software, what is our benefits, where do you see advantages in the market, and how could you sell our software, and what are the benefits. This is basically the topic of this webinar. It will be all recorded, so if you want to send this later to a colleague or want to relook it to see some extra details, that is possible. By the way, if there are any questions during my presentation, please put on your microphone and ask that directly, or an alternative, type directly the question in the conversation so that I can stop and answer the question directly. I think that is a better way than save all the questions for the end. Okay.
By the way, by default, your microphones are turned off. So if you want to ask some questions, you need to turn it on.
Okay. So what are we going to discuss here? I would like to start first with a very short introduction of the SDC Verifier program and what are the benefits for the Ansys user workgroup. Then I will go a bit more in depth over on our program structure and some details of the extra functionality we offer. And then in the end, I will end with an example of a full project. The intention is that we will have follow-up webinars where we, for example, show in a real life presentation how the look and feel and how the workflow progress in the program itself works. But for today, I would like to only talk about what are the capabilities, what are the nice features, and so on. So what is SDC Verifier? It does code checking and verification according to rules and standards, and it does it directly within Ansys Workbench. So there is the big benefit of this is that you can work in your existing model, and you don't need to build a separate model to do code checking. So that is a big benefit compared to using another separate code checking program, as for example SAP or SAX, and then import the SAX model into Ansys and then restart over again and use Ansys for some detailed results or for more complex situations like plate buckling, nonlinear modeling, all these kind of things. So the biggest advantage of using SDC Verifier over all these other code checking programs is that you can do that within your same Ansys working environment, and that you use a single model. So that is a very, very big time saver. Okay. So it works directly within the Ansys environment. What are the extra things what SDC Verifier adds to the Ansys program? I'm going to show you that through this sheet. This sheet will come back a couple of times. Basically, is we start with your FEA model. So if you start with your FEA model in Ansys, we add these extra things to the working platform, and all these things are necessary in order to be able to calculate according to standards. I will go through this quickly, first step by step, and then later more in detail, and I would like to convince you that these extra steps are not only necessary if you do code checking, but also if you want to do a lot of modifications, or if you want to automate and optimize the process of calculation. So from a FEA model to all your calculation setting, and in the end a documentation of all your results. Also for that, SDC Verifier is very well suited. We have already a lot of standards incorporated in the software. You can see them here in the middle, and we have separate parts which are necessary in order to make code checking available in the FEA model. First, we have an extra tool to make a lot of load combinations. In general, rules and regulations require you to calculate a lot of different load combinations according to different settings and different safety factors. So we have an extra tool to make all the load combinations possible and have a nice overview of what has actually been calculated. That is the first step. Then we have a part on recognition, and recognition we need because rules and regulations are based on structural items and not on finite elements. So in order to give the user the flexibility to build up a model the way he wants, because he needs that for accurate stresses, for plastic capabilities, for post buckling, whatever. You have a lot of different reasons to set up a certain mesh size. With recognition, it's possible that we recognize from your FEA model the different structural parts, and we do the checks based on these structural parts. Then we go to the next part. Of course, if you want to check according to rules and regulation, we have a checking module. Contrary to other code-based programs, our checking model is completely open. All formulas can be seen and copied and modified, and then saved under another name, and even password protected again, and shared within your company. So that this gives you a much extra flexibility in the usage of our code-based software compared to other programs. And the last part, which is also very, very important, is automatic documentation. We have a very extensive module which makes it possible to make a complete calculation document, a complete document of the model description report, and that documentation is an absolute necessity if you want to convince notified bodies that the calculation you did is correct according to standards. The requirement is that you, for every load case, you should show the results, and if you don't do that automatically, that is a lot of work. So SDC Verifier helps you throughout the process, from the moment that your FEA model is finished, and then the full engineering process from load combinations, recognitions, checks, and automatic documentation. You set that up once, and then you can reuse that. And if results are not satisfactory, you only need to update your model, and you can click on rerun, and the full process from so the steps 1, 2, 3, and 4. So the load combination, recognition, checks, and automatic documentation is done in an automatic way. Yeah, so that is a very, very big time saver. So maybe I'll show you a bit more on recognition of structural items. What is that actually? We can see, for example, if you have a lattice structure, you need to do checks on the beam members, which you can see. I think, Oleg, is my mouse visible?
Sorry, my microphone was off. It's visible, but yeah, it's just a small red point.
Okay, maybe it works better like this. Yeah. Okay. Yeah. So if you want to do a check on a lattice structure, you need to follow the rules on beam members. So that is the first thing we recognize. We recognize all beam members, and as you can see in the picture, you need more than a beam member does not necessarily consist of only a single beam element. So the first step is we recognize all these beam members in a full lattice structure. The second thing is we also recognize all joints. So all these connections, you have in standards a huge library of geometric items and how to treat these connections according to rules and standards. So that's the second thing that we recognize. The third one is welds. If you want to calculate the fatigue calculation or structural strength, taking into account the weld strength as well, you need to recognize all the different welds and also need to see the different behavior of, for example, a crossing weld or a weld tip or a continuously weld. So that is what we recognize on the right. For stiffeners and plate fields, we do basically the same thing. We find in your model all your plates, all your stiffeners and all your panels, and then you can do checks based on that. Besides this recognition, there is under the hood, so to speak, there is also something else, and we automatically transfer the stresses according to the problem you have. So if you have a plate field and you need to do a plate buckling check, we automatically transfer the stresses from the element direction into the plate direction. The same for welds or beam members or joints. Yeah, so this thing is as you hope it should work. It is completely automatically, and you don't have to worry about setting the coordinate systems of elements or stuff like that. You don't need to worry about setting these in a correct way. Okay. So after the recognition of...
For a second, sorry to interrupt you. There was a question from Roberto Silva about are any type of shapes available for our recognition, so like L shapes, T shapes, etc.
Yes, we have L type, I shapes, U shapes, tubes, rectangular tubes. We have the most important ones from the AISC and Eurocode. Does that answer the question? Okay.
Yes, sir. Thank you.
Yeah, I cannot see the list. Maybe no, this one. No. Well, Oleg, if you just transfer the questions to me, then that works just fine. Because for some reason I cannot see the list of comments. So the next thing is what codes are implemented. We have a lot of codes based on offshore and maritime industry. For example, the NORSOC, DNV, API, ABS, ISO. These things are all maritime and offshore based. We have civil engineering codes, which are the AISC and the Eurocodes, and we have crane and heavy industry based codes like the DNV and FEM. And again, I already told you that all these codes are completely open, so you can see in the if you open a check, you can see how these checks are how it's structured, in including what formula is there, what is the reference, all these kind of things. And if you want to change certain things, you can copy them, modify them, and set them according to what you like. If you want to combine certain standards together, or if you want to develop your own industry-based or company-based design standard, that is possible. Okay, then the next part is the reporting. As I told you, we can build very extensive reports. I will in the end show you an example on how extensive it is, and in a future webinar we will show how quickly you can set up these things. So although it is a very lengthy documentation, basically it is only computer time that you spend. Building the description of your model is in engineering work, I think less than 30 seconds. You click give me a total model setup report. You select whether you want to have it in PDF Word, or Word version, and you select if you want to see a preview first or directly generate the full report. I think that is about it. And then for the calculation structure for every load set, you can set up in detail what views do you want, what do you want to select, what tables do you want, what table results, and copy that to all other load sets. So you set it up once. That maybe takes a bit more time. Let's say if you want to have a really nice report, you spend 10 minutes on one load set to show everything you would like to know. Copy all these settings to all other load sets and load groups, and SDC Verifier does the automation in generating all these reports for you. Yeah, we can build PDF documents, Word documents, and PowerPoint presentations if you want. Okay, so now we go back to the. I think we discussed the full functionality of SDC Verifier, and the nice thing is I cannot point that out as much as possible, because that is the extra time-saving benefit. If you have your model set, if you have your calculation setup done within SDC Verifier, you only if you need to do the design process is only okay. I make changes to my FEA model, and then I can click on rerun. Give me a new calculation report, and all the load combinations, the recognitions, the incorporated checks you set up, and the full report the way you want it, with the same views and the same things, is automatically redone for you. The only thing which is different is the end results, of course, because that is due to the change in your FEA model. So that is a very, very big time saver. Yeah, so if we look at the overall time benefits, so besides all the calculation possibilities which we have extra to offer compared to the standard Ansys solution, it is also a very big time saver that you have a completely reusable calculation procedure, that you have only a single model in your to use for FEA calculation, so you don't need a separate code check program and Ansys for the detailed results or for the more complex simulation calculations. And you get your results directly according to the requirements, and you can set up all the required plots and regulations into the reporting tool and store all that together. Yeah, so and you only need to click update. So if you compare, if you make an estimation of how much time you can save in a real engineering structure, you could save, if you need to have a separate code base program and an Ansys model, you can save in the modeling itself. But the biggest time saving is on the reporting, although that is not the biggest part of the total workflow. You can save a considerable amount there, and in the engineering process, updating your model, rechecking your results, comparing changes in your design compared to the previous one, all these kind of things, because everything is automatic, you can save a lot of time also there. So in overall, you can easily reduce the total engineering time by 40%. Yeah, so that is, I think, a very good argument for clients to buy SDC Verifier together with Ansys.
Okay, Walter, there was a question from Paul. Why would someone want only the report generator?
If you only want to have, if you don't need code checking according to AISC rules, or if you're happy with only stresses and displacement results, but you need a lot of them, you could go with only reporting.
Okay, and the other question is, how is redesign automated in SDC Verifier? Paul, you're also free to turn on your microphone and ask those questions yourself.
Okay. Thanks, Weld.
Yeah.
This one might need a little bit more explanation. I mean, you said that you can do automatic. You're saying calculation updating and design changes.
No, the design changes you have to do for yourself, but it's only the design change you have to do. You don't need to reset the analysis, recalculate, do the review, comparing results, because you directly make a report and you can compare two design reports one after the other.
Right, so it's automation of the report, not automation of the design change.
Automation of the report and the full calculation process. You don't need to reset your load cases, all these kind of things. Yeah, so you're much quicker in setting up and ask questions like what if. That's much easier. So that there is your, in the process, a very big time saver. Another nice thing is you save the time where the most valuable time you have, that is close to the deadline, because you have set up all the calculations the way you want them, and if you have some last minute change, that is not a big deal. You apply this last minute change and you rerun the full calculation report, and within an hour you have a completely new final calculation document, which is a very nice thing to have close to your deadline.
I guess where I was coming from, that a lot of people ask about, when they're doing redesign, they're changing sections for a steel beam. Mm-hmm. And where is that change done? Is it done in SDC Verifier and then feeds back into mechanical, or do you have to go back to the mechanical model?
Any modeling changes, that is all. Ansys is very good in and very quick in making model changes. So we only do the post-processing and the calculation process.
Right, but I mean, perhaps we're getting into too much depth, but I know some other systems, they can do the, say, the section change without having to rerun the analysis. It's just purely a post-processing exercise. So I'm just wondering whether you can do that in SDC Verifier.
Yeah, we have that on the list as an improvement.
Okay.
That we check according to the different rules and say, okay, according to this rule, you could save 15% of the material, but this one you could do even with 30%, and then you take the maximum of all these updating modules. Okay. So the calculation is ready for it. I also know how to do that, but that's not yet implemented. That's something which will come later. Does that answer your question?
Yes, thank you.
Okay.
Okay, and we have another question from Carlos Franco. Is there more information of API inside SDC Verifier that we can share?
We use API basically just to communicate with our calculation tool. So the idea is that you can use SDC Verifier and changes in calculation methods without the need to program in API. I don't know if that answers your question.
Maybe, Walter, I think maybe it's a question about how to write formulas that what we have. Is there examples of our
later on a sheet on that? How do we make a detailed? Can we make a custom check? And I have a very simple example which I think answers that question. Okay. Then I would like to finish the introduction part of SDC Verifier, and why would you want to sell it? Well, of course, is the first thing is if you sell SDC Verifier, you can get a margin on that. That's the first thing. But the other thing is if you use SDC Verifier, that enhances the capability of the Ansys platform, and that results in more use of Ansys instead of using a separate code check program and using Ansys only for a part of the complete problem. So with SDC Verifier, you extend the capabilities of Ansys, and therefore you will probably sell more Ansys users, also users which for which code checking is an absolute necessity, you now can reach and sell to. For the first quick step to be able to sell, I would suggest to point at the customers who use the old BeamCheck and CivilFem programs. I think the BeamCheck is called Beamst or something, and FatCheck for fatigue. Those programs are not supported anymore, but you still have customers using that, and we want to offer them a discount equal to their original expense of Beamst if they buy a floating license from SDC Verifier. So I think that is a nice quick start to get your old customers to the new SDC Verifier platform. And also an extra comment is you can make them happy again, because they complain that these programs are not supported anymore, and while the code checking needs to be updated because you have new versions of codes, and with SDC Verifier you can directly go into that and also offer a much easier to use platform.
Yes, Walter, there was another question about the standards. Are they current, and are they updated in new versions of SDC Verifier?
Yes, they are current, and they will be updated constantly by us.
So yeah, we have a maintenance which includes the all the product updates, and in new versions of SDC Verifier we are adding new versions of standards. So we have a list of standards which are going to be implemented in the nearest future, and yeah, it's going to be included in new versions.
Okay, well, of course, if you have customers with code checking demands, SDC Verifier can be a nice thing to offer to them. Customers which have very high reporting demands, so big companies which need a lot of reporting and need them to be automatically stored, you can also combine that with PDM solutions, so that you also get track of what has been done. And a last thing is, if you have customers with very extensive calculations in the cloud, making reports, calculation reports, and send them back through email is a huge reduction in necessary bandwidth. So that can also be an option in customers. And of course, for new customers, you can go find the traditional standalone code checking customers. They can now switch completely to the Ansys platform together with SDC Verifier, and again, be a complete solution provider.
And here is a question about how do we compete against software developed specifically for the civil engineering, like SAP 2000?
The nice thing is the drawback of these dedicated programs is that besides, well, they are of course very good in the code checking part, but it is only code checking. It's only based on linear calculation, and there is no extension possible. So if a customer has a sub problem which cannot be solved by the standard simplified formulas which are in this code checking, you're stuck. If you use Ansys and SDC Verifier, there is not a limit. You can build detailed models, you can do plasticity, you can build creep, you can do post-buckling. You have a million of extra options in the Ansys platform which can help you to prove that your design is still okay, which all these dedicated code check programs do not have. And with SDC Verifier you have and Ansys together, so you have the best of both worlds. And that important to point out that there is you can stay with the single model. If you use let's say SAP 2000 and the customer say, yeah, well, for these details we use Ansys, you still need to export all the load all the loads and the part. You need to isolate the part where you want to do detailed analysis on, export the geometry, export the loads, import that all in Ansys, do the calculation, do the nonlinear stuff, and then it is very hard to get the nonlinear or detailed Ansys analysis back into the global code-based program. So it is a very tedious design process if you have something, if you expect anything which is off standard. So if you have a design where you expect that you cannot, where only code checking is not sufficient, Ansys plus SDC Verifier is a much better solution than, for example, SAP 2000. Does that answer the question?
I hope so.
Okay, good. Let's go back to the explanation, a bit more explanation of the program structure. I think you got a general idea, but I want to point out some extra details and make it a bit more clear what are actually the strong points of SDC Verifier. So we have this full calculation process. One of the things which I did not show is the load combination, so that's the first thing what I would like to show more in detail. This is an example of a standard. I think it's a crane, a standard, and all standards work alike. And they have a specification with a lot of different loads. For example, hoisting load or wind load or ice load or earthquake loads. So you have different origins. We call these individual loads, and you need to combine them into different load sets. So one row of this is a load set. So you need to combine gravity plus a hoisting load plus a side wind, something like that. And you need to make a huge number of load sets. And then, so that's one thing. And so you need to combine loads together with different load factors. So you need some kind of matrix-like solution to make all these load sets. To make all these load sets, we can do that within SDC Verifier, and we can also do import-export within Excel. And the other thing is you need for different load sets, for example, operational conditions or operational conditions with wind, or if you do the maritime equivalent, you have the still water conditions and the operational conditions with wind and waves, and then you have survival conditions. They have these. You have to group the different situations or different load sets according to the classification, because a still water condition has a much higher safety factor than the extreme survival conditions, where a safety factor of 1.1 is even enough. So you have different checks on different load groups, and you also have different safety factors. So you need to treat the different groups in a different way. So we have in SDC Verifier a method to not only combine the load sets linear with the individual loads, but you can also combine different results, load sets or individual loads, together in groups and treat them according to the requirements. And by the way, if you have all these load sets, if you do them by default, everything is linear combination. If you're not sure, or you see large displacement and you think, well, I think this linear combination, I don't trust that, you can click on SDC Verifier and say, okay, instead of linear combinations, do the nonlinear, so the large displacement effect, let that calculate by Ansys, and then you get the large displacement result and do the code checks based on that. That is another difference compared to, for example, SAP 2000. SAP 2000 nonlinear, they have a very simple first step nonlinearity approach, but that is by far not the real nonlinear capabilities which has Ansys. And so with this calculation structure, we are already prepared for that. Of course, it's much quicker if you do only the linear combination, but the nonlinear calculation is only a different setting in the SDC Verifier settings.
Yeah, Walter, there was another question which
Yes.
I already responded in chat, that can we apply the wave loads as inputs? And here, with all these combinations, you can widely describe how we can apply any kind of cyclic loads for the fatigue checks.
We have a specific wave load tool, but I think that is not ready yet for Ansys. But we can use the separate the separate loads which come, for example, for Aqua. So if you use Aqua to make detailed wave loads, we can incorporate that as separate individual loads and make the different combinations for the different wave directions. Does that answer the question?
Yeah, and also Paul is saying that mechanical also generates the wave loading. So if we can import these loads, then yes.
Walter, I think there's a slightly bigger question there, because I'm not quite sure. Fran's asking about, can fatigue be calculated with wave loads? So FatJack, for instance, and you mentioned that.
Yeah.
Was very specific fatigue for tubular or beam connections.
Yeah.
And I think the big differentiator there over conventional fatigue is that it had stress concentration factor formulations built in.
Yeah.
So that's a big area, and I know we've historically talked about making an ACT extension to allow that to happen. Is that in your plan?
We currently have not implemented it, but that is the first thing we want to implement in, version 5 is released today. So this is the first thing which will come next. We focus completely on, we have fatigue with details, and you can set it up, and I'll have in the next sheet is on fatigue, so I can show you how that works. But the different stress concentration factors calculated according to standards is something which will be implemented in the next version, for sure.
Thank you.
And we also we will build an extra tool to which could simulate all the capabilities of SACs, for example. We are building a wind load together with the wave load, and put that all together in an easy access separate window to show to SACs customers that it is much easier to use SpaceClaim, Ansys, and SDC Verifier. Yeah. I would like to show you, explain a bit more on how easy our code checking is compared to ACT programming. Of course, those who use ACT programs say, well, it's fairly simple, but the majority of engineers, they are allergic to any type of programming. And this might be a much easier and a lower step decision to change your code checks in SDC Verifier, because you only need it's kind of MATLAB-like environment. And what you see here is an example of the ABS rules where you have different allowables for different types of stress. You have, for example, yield divided by 2.5 as allowable stress for shear, while for uniaxial stresses you have an allowable stress of 1.67. And for the equivalent or the comparative stress, as it's called in ABS, you have even a lower safety factor. So how do you do that? We use yield. We make a parameter which is called allowable stress. We show the stress, that is the yield divided by 1.67 for all stress directions. We override that for the 3 shear directions. And for the equivalent or the comparative load, we do yield divided by 1.43. And then we go to the next step. We have something which we call a utilization factor. That is the stress divided by the allowable stress. We do that for every direction. And we do this for the 7 directions, the 3 XYZ direction, the 3 shears. The 7th one is the equivalent stress. And we add an 8th one, which we call the overall. And in this stress, so we set for the 7 direction stress divided by allowable stress. and for the last one, the overall, we say, okay, give me the absolute maximum value of the previous 7. So me, X, Y, Z are the directional ones, the 3 shears, and the equivalent one. And so I get, for a single picture, I can set all the stress results. I can guarantee that the stress divided by the allowable stress is fine for all direction in a single plot. And so that saves you a lot of time in checking 7 pictures, and now you only need 1. So that is a fairly simple way to do it. Now we go back to the fatigue checks. If what you see in the upper left corner is a beam model with some details incorporated with plates. So what we can do now, it's not on this sheet, but I can explain that you can set a classification factor for the different joints. So for any connection, you can set a if you use an heavy equipment, heavy lifting or hoisting, for example, Lloyd's Lame standard, you can set a weld class which varies from K0, which is a very good weld, to a K4, which is a very bad, very high stress concentration factor, or you can set a fixed FAT class for all the stresses in all directions. So you can already do the fatigue checks based for every joint, a multiplication factor, or a lower FAT class for every connection, and you can set these FAT classes for the different joints already. But we are going to automate also the second part, the stress concentration factors, based according to the rules automatically, so that you don't have to set that. So that's the first thing. But besides beams, we can also do plate models, and the nice thing of recognizing welds is that we can set different FAT classes or allowables for stresses perpendicular and stresses along the weld. Yeah, so for stresses along the weld direction, you have a fairly high FAT class, while for the stresses perpendicular to the weld direction, you have a much lower FAT class of, in this case, 90 megapascals. So you can see in the picture that the result is much more realistic if you add this FAT class automatically. And the nice thing is that you can not only you recognize the welds, so you can treat welds different from non-welds, you can also make a division between stresses, the stress direction, whether it's along or perpendicular to the weld. So another example of fatigue, you have the different FAT classes. You can the picture, the previous picture, and also this picture over here shows that basically fatigue is always the highest calculation, the highest utilization factor of fatigue are almost always in welds or in stress concentration details. So you can see that you get pictures like this, and then a nice extra feature is that you can show only the important results by selecting only the welds with free edges, and then you get pictures like this where you see only the welds and you can peep through. You directly see from all sides. You can look through your model with a plot like this. And yeah, this picture here shows that this fatigue module is a very good predictor of fatigue. We found here, this is the crack sizes from here. I think this is around 30 centimeters. So that's more than a foot for the Americans. So that is a crack we found after the calculation. So I think that's a nice example of which proves that this method with FAT classes is actually a quite good method. The next thing with welds is, since we recognize all these welds, we can now calculate the requirements for a weld. If you do a hand-based weld calculation, it is allowed to calculate the full weld capacity and compared to the total load on the weld. If you do that, if you have an FEA solution, you will find peak stresses at the begin and at the end of the weld, while the complete weld, according to the standards, is still okay. So the only way to make within your FEA model the total check complete is summarize the total load over the weld. That's what you see here. The total forces over the weld are so in the three different directions, including the moments, and then divide that by the total capacity of the weld. So in this case, you can save considerably on the total A height. Yeah, by FEA engineers tend to like to say, okay, the A height is always half the plate thickness, but yeah, that is a hugely conservative approach, and with this method you can set detailed A heights for every weld, fairly simple and semi-automatically. Yeah, so there is a very big saving in weld heights if you base your calculations on this model compared to directly uses the stresses for each element and try to transfer that in some kind of A height by basing yourself only on equivalent stress at the edge. The same is valid for buckling. If you want to calculate plate buckling, you need to recognize the different plates. Of course, the stresses in the different directions is automatically set as well. So we transfer the stresses internally, and you get pictures like, okay, this total plate buckling, this field buckles, yes or no, and you can plot that also in tables. And of course, you can add these things into your report as well. You can also get, not only for every load case, you can set this, let this calculation do for every load case and plot only the load group results. So give me the worst results for 1000 load cases, and then you get a single plot what is the worst result. So that is again a very big, besides the possibility to do that, it's a very big time saver that you can automatically do these checks not only on the load set but also show them in the group. We have beam member checks. I already told you that it's not necessary to use a single element to do that. We store the results over the long set over the full beam member, even if you have more than one element, and you can get plots like these, or you can plot it again in a table where you can see the different parts. So you have the total actual utilization factor, the bending utilization factor, the shear, and everything combined. So if it's not okay, you can easily see in these tables what is wrong and what should you check, what is the cause of it. Is it shear, is it bending, is it buckling, all these kind of things. For joints, that is again a very hard thing to do. You cannot calculate these things by hand. You need to recognize for each joint, you need to recognize the geometry. So what is the diameter of the brace and the cord, but also the different dimensions. So you need the classification of the geometry, but you also need to do a classification of your forces. So whether this force goes into this tube or in that one makes a difference in the code check rules. Yeah, and if you have the bad luck that this force completely goes through the cord into the brace opposite to that, you have even a much higher utilization factor, and because you more or less squeeze your cord. All these things are taken into account in API rules or the ISO rules, and you cannot do this by hand. Even for a single load set, that will take you, I think, an hour or two for a single joint. Okay, again, an example for custom checks. You can add your rules For example, for bolts, if you make beam elements and treat them as bolts, you can by using these 4 formulas, you can make a bolt check to see whether they slip or whether the shear is too high. I'll skip this because I think we're running out of time. The other one is reporting. As said, you can do a lot of reporting, and you have a nice setup in bookmarks to quickly go to the results you want. Yeah, so if we have a model setup report which gives you a complete description of your design, what is the weight of that plate or of that beam or of that material, and it's completely automatic. You just select give me a description of the full model, and it takes a couple of minutes maximum if you have a very large model, and then you have a full calculation report including all this bookmarking, so it's also easy to read. So instead of sitting next to someone to see how the model looks, you can do that in a PDF report, and you could even do that on an iPad, for example. Calculation reports, you can set up the calculation for each individual load, so you can check the results per load. You set up the calculation for a single load set, and then you copy that to all your individual loads and all load groups the same. So you set it up. Maybe that takes 10 minutes, but then you have a report which is exactly the way you want it, which is very extensive and is exactly the same for every load set. So if you want to send these things to a regulator, this is a very big time saver. I don't know if we have time for an example. I'll quickly run through this. I think I can do that in 5 minutes. This is an example of a 30-year-old crane, so it's nice to see again whether fatigue is fine. We use a mixture of beams and plate models. That is another thing which is not possible in standard code-based code check programs. They are either only plates or either beams. With SDC and Ansys, you are far more flexible. So we have, for all parts where we expect stress concentrations, we build plates, and the edges which are not so highly stressed, we keep them as beams. We have 11 different positions, so we set up for every position we need to set up the situation. We have, for a single situation, we need to apply, of course, the gravity with the partial load factor. We need to set up the hoisting load. We need to apply the situation whether a crane moves or not, so that is in that direction. And we also have the situation where the trolley might move, and the acceleration of that trolley needs to be taken into account as well. So we have, for every load situation, for every load position, we have 4 calculations to do. And if you want to do the same thing but then with wind, you have 4 times 11 is 44. 44 solutions, load sets which you need to define. If you have these 44 and you want to add that with wind, you have 3 wind situations, because you have wind from the back, wind from the front, or wind from the side, and then you take advantage that this is a symmetric solution, so wind from this side or from the other side results in the same thing. So that gives you 3 times these 44 situations again. Yeah, so you run out of possible calculation routines very fast. And with SDC Verifier, you just use a very big matrix, as you can see over here. If you want to do a fatigue check, you are not done, because you need to add also the average load instead of the maximum load, because if you once in a while lift a maximum weight container, that you need to take that maximum weight for the static stress into account for the maximum yield, but for fatigue you need to use the average load and also the empty one, because you look at the stress difference in a situation. So you need to have the empty loaded situation and the average loaded to be able to make the fatigue possible. We show you also how to use different groups. In general, you need a couple of groups to do static checks according to still water conditions or survival conditions, but you can also use the same method in fatigue groups, because you can set for different movements, for example from here to there, or from 1 to 5, or from 3 to 5, or from 2 to 7. You can set make a different group and set the number of load cases here. So here we transferred this complete table into different load situations according from position 2 to 6, from 3 to 7, and so on. Yeah, so this grouping effect makes fatigue checking very, very simple. And just to show you what you need to do in the group, you have the load calculation. On average, if you go from 3 to 5, that is this position to that position, we need to have 3 situations. So we have average load at position 3, 4, and 5, and also back, because there it's empty. So for this group, you need these load set combinations. So you set up the different groups, you set the number of load calculation, you set the FAT classes, whether there's a weld or a non-weld, and then you can get your fatigue results. You can get in reporting, you can get stresses and displacements, of course. You can do static checks, you can do the fatigue checks, and if you go more in detail, you will see that you find here very small overshoot, very small location, but a very high overshoot in the fatigue utilization factor. And you see when we did this inspection, we found cracks this 3-4 centimeters, so 1.5 inch in actually at the spot what we calculated. Yeah, to summarize it, so with this SDC Verifier, if you use this crane not after 30 years, but if you do that in the design process, you can save. You set up your initial design, you do the full calculation, and if something is not okay, you change your model and you rerun the full thing. And you have set up the calculation completely already. So you set up the calculation tool, and you only need to change your design, and that's it. I think that is a very quick overview of what SDC Verifier is. If you want, or if you think, well, this is a nice thing to show to our customers, and it definitely helps us selling Ansys, well, leave us at least your email address. You can ask for a trial, a download. We will come up with new webinars with a bit more dedicated examples, including directly how does it work, so that you can repeat that yourself at home too. You can also refer to for example Houston, Rotterdam, or the offshore energy. We are at different exhibitions. The OTC is the most famous offshore event of the year, so we will be there. The TOC is for heavy port equipment. That will be in June in Rotterdam, and offshore energy in the Netherlands, in Amsterdam, is also a very big exhibition. And yeah, you can refer your customers or yourself to this event. We can also help you in setting up webinars for your customer. We can help you with making use cases. If you have a customer with an example file, we can help you setting up, or we can at the beginning we will do that completely working out, and we set up a webinar just like this, but with you and your client, in order to give you a head start. Contacts. If you
Better.
that, I think that's what we what's there. We'll follow up with a new webinar, but yeah, the question is, do you like what you have seen today, and do you think this is going to help you in your sales?
Walter, we still have some questions to be responded. Do you hear me?
Mm-hmm.
Yeah, so the first one is, does SDC work with spectral analysis?
Yes, SDC Verifier works on any result. So if you want to do spectral analysis and combine that with fatigue, that's definitely possible. You can set a load factor or a number of load sets based on this thing. It's basically more or less this approach, but then instead of results which are based on linear combination, you can use spectral analysis for that. And you can also combine so this percentage for with this frequency and that times the other frequency load, and you can make groups out of that as well too. Does that answer the question?
Yeah, I think so. We also received a lot of questions from Bashar by email, because yeah, he's using this, he's looking at the webinar from his phone, so it's not possible to type in, but yeah, he managed to figure it out and send us an email. And the questions are we planning to include any modules from ASME designed by Analysis?
Yes, we want to, besides fatigue, which is a priority, the other priority is ASME coding pressure vessel codes. They are quite simple to implement, and we already got quite a lot of requests. Could you implement this? So that's definitely also included in the next update.
Okay, then the next one is that he heard from SOX a year ago that they will cooperate with FIMIP, and they will create a submodule for FEM to do all the local checks for complex joints.
Mm-hmm.
They will automate the hotspot stress method in that module. So are we planning to do this as well? Well, yes. And the hotspot method is the questions.
The hotspot method is going to be included within the fatigue update. So the first fatigue update. What SACS want, that's new for me, by the way, because we already have that in VMAP. So I think that is we already have that, and well, I wish them success in figuring out to do that based on because SACS comes with the complication that they have specific demands in modeling. You need a single element for a beam member. We don't have that, and yeah. So the hotspot stress method we recognize all the welds. We also will automatically recognize the nodes to make the hotspot the interpolation figures. Yeah, so that will be, we are not only going to implement that will be also a completely automatic routine, because it is a very tedious process to make these hotspot stresses, and we can automate that completely. We are actually already halfway. We can recognize the nodes we need for the interpolation. We can do the interpolation, but we need to transfer these results back to elements to show it on a plot. So we're halfway.
Okay, there's a few more questions about the standards. First one is fracture mechanics from engineering critical analysis.
Yes.
BS or DNV standard. And the other one is what are we planning to do for damaged structures fitness for service assessment with API 579? I'm not sure. Well,
okay, the BS and DNV codes I know. We have them on the list, but it's not going to be the first update. We have all these things which we which you need. We recognize the weld, so we know the total section height, and we can calculate for the different situations. You could already calculate the critical length based on formulas. I have a student who already did that, but implementing the full BS or DMV will take somewhat longer, but that is definitely a very high priority. But that's not going to be the first step, but probably the second. So I hope to have that next year in December included. And the API 579, I don't know that, but I suppose that is more or less the same issue. But send us an email, a reminder. Look, we would like to have these codes implemented, and then we can put it on the list, and for sure that we don't forget that. And we also see, we can, if we get requests from different customers, then we can put that higher on the list. But the fracture analysis, it is a bit complex. I hope to have to at least in part solve that question by the end of the year. Yeah, so the standard fatigue rules for stress concentration is, I hope to have that around at the end of the summer, and then in December these fracture mechanic checks.
Okay, and the last question about the standards is codes for the aircraft structures.
Yes, we have some NECA plate buckling implemented already. It's not in the wizard, but it is internally, but that is not completely checked. We also work on, I have a student figuring out how triangle plate buckling works, so we will have that implemented as well. But it would be nice if you can also send a list which codes you refer to, because we now have only plate buckling, but if you have extra things you would like to have implemented, we really would like to know that.
Okay, and also the thing I think we didn't completely cover is the process of licensing and Ansys App Store. There was several questions. How are we going to sell it? Yeah, I'd like to say that we are going to send the email with the procedure of sales and also the price list for all the attendees, but maybe you can say a few more words on the sales process.
Well, if you are an Ansys partner, then that is simple. You can make a direct agreement with us, and then you can do direct sales, and we have a separate licensing, so that is simple to do. If you are Ansys direct sales, you can use the Ansys App Store link, and then you get your percentage through that. So these two options, that's what we have.
Yeah, and we will send the document with prices.
The document with prices and details how to do that. I hoped to have everything on the App Store, but there is a bit more paperwork involved than I expected, so we cannot just upload the program, set the price list, but we need to do a bit more. But I think in 1 or 2 weeks that should be completely finished. So if you want customers to test it, you can already send a trial, and if they want to buy it, you just they need 2 weeks at least trialing and testing it. Then in the meantime we have set up the App Store, so also for Ansys direct sales they can already sell that in 2 weeks.
Okay, I think we run a bit out of time, and we've covered all the questions. So
okay, well, to all, thanks for the attention, and we will follow up with all these questions. We will put these also on paper, so that might you miss something, that you have it there, and we will also, everything is recorded, so you can send this webinar also to a colleague if he's interested as well. So
contact us by phone, email, or any information Wouter has shown, or it's in the bottom of all our emails. In case of any extra questions, you can always reach us by
the connections or just send me an email. And anyway, we will contact you by phone or by email how to proceed. Yep. Well, thanks again for the attention, and I hope that we will quickly make progress and for sales. That's it, I guess. Any more questions?
No, I think that's it.
Okay, well, thanks for all. I'm going to close the session then. I stop the recording now, and well, we will follow up. Okay.